Welcome everyone. So today we are going to introduce the idea of compounding. Some of these concepts you probably have seen before in a typical pre-calc class, but I'm going to focus on pattern recognition to build a formula from scratch, and also share with you some financial notation so you can speak with confidence as you begin to invest money in your future. So let me begin with a basic concept, which is let's say you're investing a principal of $100, okay? And let's say your rate of return is 5%. So after 1 year, we're going to call it A subscript 1. A stands for accumulated amounts. After 1 year, you should have $105 if it makes sense. And that comes from the fact that you started with 100 and you are getting an interest of $5. So 5% of 100 is $5, and 100 plus $5 is 105. I am not too concerned with this value, even though it's true. Jumping from 100 to 105 is not going to be helpful to me. I would rather focus on this expanded expression. And here is why. Because I want to build a formula that will enable me to figure out how much money I have at any given time. Okay? So this A1, which is the accumulated amount after 1 year, is 100 plus 105, 1.05 I should say, times 1.05. I'm going to focus on this instead of this, okay? This is exactly this, but I'm going to focus on this. So after 2 years, or at the end of your second year, you should have what you started with plus 5% of what you actually started with, right? Just like here, the principal was 100 plus 5% of the 100. Now I have this amount, so it's this amount plus the interest, which is 5% of the amount. But if you notice here, I have two terms, this term and that term, and they both have this piece in common. So I'm going to factor this out, okay? And I'm left with 1, because if you multiply this by 1, you get this. I'm left with 1 plus 0.05. Think about this. If you multiply this by 1, you get this. And if you multiply this by 0.05, you're going to get this. Now, this happens to be 1.05, which is 1.05 squared. So I hope you begin to see a pattern at the end of the second year. If you go back here, at the end of the first year, I had 100, which is the original amount, times 1.05 to the power of 1, which resembles the subscript here called 1. At the end of the second year, I still have the original principal. See, I'm trying to figure out the amounts based on the original principal, not what you accumulated after 1 year, okay? Times 1.05 to the power of 2, and that too happens to match the subscripts in here too. Using parameters, just letters, I start with a principal P, which is the accumulated amount at year 0. In other words, if I start investing $100, a principal of $100, right now I still have an accumulated amount of the same $100. Make sense? And after 1 year, you get the principal, the $100 plus the interest. The interest is the rate times the principal. And what I'm doing here is I'm factoring out P. And that leaves me with 1 plus R to the power of 1. And that one matches that one. Let's do one more step. At the end of the second year, I start with this, and then I multiply what I have by R again. Same thing I did here. Okay? And I am not going to FOIL this stuff. I'm noticing that this amount, this quantity here, shows up again. So I'm going to factor out P times 1 plus R. That leaves me with 1 plus r. And 1 plus r times 1 plus r is 1 plus r squared. So you could imagine what's going to happen at the end of the third year. I should get my original amount called principal times 1 plus r to the power of 3, right? And therefore, at time equals t, I don't care what t is, 10 years, 20 years, a million years, 5 years, I should get the original principal times 1 plus r to the power of t. In fact, if you go back here, I can rewrite this with this pattern. A0 is p times 1 plus r to the power of 0. Isn't it true that's 1 plus r to the power of 0, 1? You know, this is not 0, so any number that is not 0 to the power of 0 is 1. So that leaves me with p. So that 0 goes here, that 1 goes here, that 2 goes there, that 3 goes there, and of course, accumulated amount at time t is p times 1 plus r to the power of t. And this is a nice, really beautiful formula. Now, I'm going to pause here and ask a question. I would love for you to stop the video and think about this question. Would this formula work for any situation? In other words, imagine so T is in years, okay? And R is the annual rates, the return on investments, an annual one, and P is your principal, and the amounts is the accumulated amount after T years. So let's say I invest for 300 days. In other words, I haven't finished 1 year yet. Think about it this way. So imagine before I finish 1 year, let's say I invest for 300 days. What do you think you're going to have according to this work? Will you have 105? Or shouldn't you? Because at the end of the day, what I'm doing here is I'm getting a 5% rate annually, but I didn't finish 1 year. I'm at 300 days or 364, not 365. What should happen? According to this formula, my T is 0. After 1 year, I didn't finish a year yet. So I'm still stuck with $100, right? So this formula, although is correct at this point, it doesn't paint the right picture because it doesn't tell me what happens if I don't finish the term called 1 year or 2 years. Imagine I invest for 2 years and a half. According to this formula, I will get credit for 2 years. I haven't finished the third year yet. And that doesn't seem to be fair, right? I invested for an extra 6 months and I get nothing out of it. And that shouldn't be fair. That's not fair. So what I'm going to do is I'm going to take this formula here. I'm going to tweak it a little bit to take into account the question I have been pausing. So what I did is I divided the rate by some number called n, and I raised it to not just t, but nt. So think about this. So n is the number of times you compound per year. So if I compound every month, n would be 12. It's true that my rate, which is 5%, will be divided by 12, which is really small, right? It's really small. But the 12 goes here as well. So let's say I invest for 2 years. Let's say I invest for 2 years. It's true that the rate will be divided by 12, which is a very small number. But instead of having 2, as in here, instead of having 2, I'm going to have 24. Why? Because how many months are in 2 years? There are 24 months, and hence you multiply n by t to tell you the number of months. If I compound every day, that means n is 365, which makes the ratio so tiny. However, you're going to multiply 2 years by 365, which tells you the number of days you are compounding. In fact, banks, they give you a rate, at some annual rate, of course, but they compound daily. So if you invest for 23 days and 9 hours, you'll get credit for 23 3 days. You don't get the 8 hours because you didn't finish the day, but you will get credit for 23 days. Hopefully you won't invest at banks anyway. That's not a good way to invest. In any case, the formula now, instead of using this formula, which assumes that I'm compounding what? Annually, which is silly, we want to compound however we want. So we're going to divide this by n and multiply this by n. So this is the formula. Now, a little change in notation. I'm not going to use the word principal P anymore. I'm going to replace this by PV, which stands for present value. This is the present value. In other words, if you invest $100 right now, the PV is $100. And what you hope to get later, the accumulated amount, we're going to call it future value. Right? Makes sense? So this is the formula for what we call a discrete case. If you compound daily, n will be 365. If you compound monthly, n will be 12. If you compound quarterly, like imagine you buy stocks and a particular stock is giving you dividends, it's usually given every 4 months. It's quarterly, so n would be 4 here, right? If you compound semi-annually, n will be not 6, but 2. There are 2 6 months in a year, so please don't say 6. Semi-annually means every 6 months, which means n is 2, not 6, okay? So let's do a quick example because I want to point out a couple of things. Number one, imagine, I don't know, you are 6 years old and your mom didn't have much money. She had $1,000 and she's thinking about you and your college when you turn 18, which means 12 years from now. And let's say she found an investment opportunity that gives her 10% annually. It's always annual, by the way. The rate is always annual. Regardless of how you compound, the rate is always annual or per annum. Let's say this money is compounded semi-annually. So n is 2. How much money will she have, right? How much money will she have when you turn 18? Well, you just use the formula. Of course, you plug in the value. PV is 1,000. R is 0.1, 10%. Semi-annual, n is 2, not 6. And then this is 2t, 2 times 12, which is 24. There are 24 months in 12 years, right? I'm sorry. There are 24 6 months in 12 years. 12 years has 24 6 months, right? Because you are compounding semi-annually. You plug in the value and you get this dollar amount. Now, I want to freeze here and point out maybe 4 things for you quickly. All right. Number one, I want you to do this on your calculator and see if you get this, because it is possible that you're going to mess up because of the order of operation. The way you do it is this. You take 0.1 and you divide by 2 and you press enter. Then you add 1 and then you press enter. Then you raise that whole thing to the power of 24. Then you press enter again. Then you hit it with 1,000 and then you press enter. And I got something like, if I remember correctly, I got something like 225,09988, something like this. Okay? Now, number 2, make sure you have 2 decimal points. Even if there is no penny, like here, I wrote 00. Okay? Why? Because we're dealing with dollars and cents. So don't use 3 decimals, don't use 1 decimal, don't use 0 decimals. You've got to use 2 decimals. That's point number 2. Point number 3, make sure you put the units. These are not tomatoes, but these are dollars. Make sure you put the unit dollars. Number 4, I use an approximation, because that's the actual value I got, plus, there is a bunch of digits here. So this is not an equal, but it is approximately, right? And finally, number 5, and this is important. Usually when we round, and I want 2 decimals, so we look at the 3rd decimal, which happens to be this 9. I'll circle it in green for you. And because this 9 in green is more than 4, it looks like I should round up. I should have written 10 cents, not 9 cents? The answer is no. Regardless of what this digit is, you must round down in this case. You've got to consider the context of this problem. Your mom invested $1,000, and after 12 years compounding at 10 semi-annually at 10%, how much money will she get when you turn 18? Well, you haven't hit 10 cents yet, have you? Regardless of this digit here, you must round down in this case. She has achieved 9 cents, but she hasn't achieved 10 cents, has she? So you have to round down. And that's my 5th point for you. So this is a very quick video. It's just a simple introduction. Pay attention to it. Feel free to watch it again. And I will talk to you later. Take care.